magnesium group 2A elements. So 2 positive, 2 negative. That's the formula for magnesium sulfate. Okay, so quite a bit of memorization that you have to go through when you take chemistry classes there. In the summer, you don't really have a whole lot of time to do that. So make sure that you use all the time that you can find to study this material, because you will be tested on these things there. Now, how do we name ionic compounds there? Now, we can actually, ionic compounds itself, it's a fairly large category there. We can have ionic compounds there. We can have metals forms only one type of ion. That mainly is the elements in the main group metal elements there. Yeah. They can only bear one type of charge. Sodium will not bear 2 positive charges. Sodium is group 1A. They can only bear 1 positive charge. Iron, well, iron can bear 2 positive charge. Iron can also bear 3 positive charge. An example that we gave you earlier today, cobalt, 2 positive charge, 3 positive charge. Titanium, positive 2, positive 4. Okay. Chromium, positive 3, positive 2, positive 3, even positive 6. Okay. So when you try to name ionic compounds there, we have to separate main group elements and the non-metal elements versus transition metal elements with the non-metal elements there. So when you have ionic compounds there, and then the first category makes it easier for us to write the formula, because the ion, the metal ion, always form the same type of, always bear the same charge. Okay, so if we know where they are in the periodic table, which group they're in. Okay, so for the non-metal, for the transition metal ionic, for the ionic compounds involving transition metal elements there, you have to specify the charges on the transition metal elements there. So give you some example. Now this is what we call the type 1 ionic compounds there. Those are mainly the main group metal elements there. And they would bear, most of them, not all of them, in general, main group elements, metal elements, and they bear the same, the charge they bear equals to their group number. So here you can see group 1A, they bear 1 positive charge. Group 2A, they bear 2 positive charge. Group 3A, aluminum. Aluminum is one of the represents one of the elements in group 3A. Okay, and then zinc. Well, these are the charges in these metals cannot be inferred from the group number there. The zinc, that's transition metal. Silver, that's transition metal. Okay, and scordium, that's a transition metal there. Okay, and but mainly when zinc forms an ion, when zinc forms 2 positive charges there. But zinc is a transition metal. You cannot really determine the charges of zinc based on the group number here, because it's actually a B group element there. So for the other type of ionic compounds, which involves transition metal, well, you have to determine the formula based on the charges there. Okay. So in this case, if you have iron sulfate, once again, always go back to the polyatomic ions there. If you have iron sulfate, the name of it would be iron 2 sulfate with the Roman number in parentheses, because sulfate ion, one of those 16 polyatomic ions we have to memorize, sulfate ion bears 2 negative charge. Okay, so iron, if this is the formula representing iron sulfate, that means iron has to bear 2 positive charge. Positive 2, negative 2 give you 0. Now if you write a formula like this, representing iron sulfate, Fe2SO4 3. SO4 bears 2 negative charge. So there are a total of 6 negative charges here. You get 2 irons to compensate. In order for the 2 irons to balance or neutralize, if you will, those 6 negative charges there, iron in this particular formula has to bear 3 positive charge. So in this case, the main group metals such as lead, thulium, and tin, they will form more than one type of cations as well. Okay, so those are the things that we need you to pay attention to. Now, when we try to name the ionic compound, the basic format is there, the name of the cation, sodium chloride, for example, sodium, plus the base name of anion. It's the stem of the name, and you add IDE to it, so sodium chloride. So this is probably something that we want you to pay more attention to, in addition to all those the details there. So for the binary compounds that only have 2 different types of elements, we use the name of the metal. We use the name of the anion there, and the base name, the stamp name of the non-metal elements plus the IDE in there. So chlorine will be chloride, oxygen will be oxide, fluorine will be fluoride. Okay. So for type 1 anions there, or the ionic compounds, the type 1 or ionic compounds there, the nomenclature is simple. These are the basic groups there. If you know the name of the metal and you know the name of the non-metal there, this is how you put them together. Okay, so calcium chloride, KCl, calcium chloride. Okay, CaO, calcium oxide. Okay, so that's how you name the binary compounds there. And again, these are the things I don't want to read through it. You can do that yourself. And the most important thing there is that you got to get used to the nomenclature. You got to be able to recognize the nomenclature so that you can, giving you a formula, you can name it, and giving you the name, you can write down the formula. And that's what we're trying to achieve. Okay. So the base name for monatomic ions there in your textbook actually gives you a list of things there, and I do not need you to memorize all of these, at least for now. But pay attention when you read the textbook there. Pay attention. Now, for the type 2 binary compounds, that is the ionic compounds that involve transition metal. And again, the Roman number is important. You have to include the Roman number in there. Okay. So for iron 2+ versus iron 3+, the current IUPAC nomenclature requires you to put the number in there. And prior to that, we actually give you different names, different spelling English words to represent iron 2+ and iron 3+. And that's very confusing, and also involves a lot more memorization there. And sometimes you see the ferric versus ferrous, and that represent different charges there. Now, we tend to make things a little bit easier now, and we try to, as long as you use a Roman number to indicate the number of charges there, you don't have to memorize all these different terms there. So for naming type 2 binary ionic compounds there, it's the name of the cation, the name of the number of the charges for the cation there, plus the base name of the anion, plus the IDE there. Okay. So for iron chloride, for example, it will be iron Roman number 2, Cl2. Okay. So that's how you name it. And again, these are the things your textbook actually gives you a fairly good summary about the nomenclature in these colorful format. So this is something that you need to pay attention to. Okay. So, and again, the key thing though you need to remember is that you got to check the total charges once you come up with the formula. So chromium bromide, chromium 3, bromine group 7A, -1. So chromium 3 bromide, the correct formula would be CrBr3. So chromium bears 3 positive charge. Bromide bears 1 negative charge. So you have to have 3 negative charge to balance the 3 positive charges. So that's something that we need you to remember. And again, here, this is the current name in the IUPAC system for nomenclature. These are the old names there. So for iron there, ferrous refers to 2 positive charge. Ferric refers to 3 positive charge. And now this obviously is way more confusing than the system, the new system here. Okay? So this new system now that lately there, as long as we know as long as we put the